Good evening. Today, I just want us to focus on what it's the circles, the circle geometries. So now, before we do anything, I would like us to do the introduction of this topic. So now, in this topic, we are going to learn of the circles. So there are 5 things that we need to always remember when we deal with this. Number 1, let me draw a circle. Yes, and let me draw my center. This dot is my center. Let me make it a little bit bigger. This dot is my center. So now, the first thing that we have to learn from this is a line. Okay, this circle, we call it the circumference. A line drawn from the circumference to the dot, it is called a radii or radius. It is called a radius. Number 1. It is called a radius. It is a line drawn from the circumference to the center. But if that line is passing through to the circumference, from circumference to circumference, if that line passes from circumference to circumference, now that line, it is called diameter. A line that is drawn from a center to the circumference, it is called a radius. A line drawn from the circumference to circumference, it is called a diameter. Now, a line drawn from an arc here, circumference here to there, that line, it is called a chord. It is called a chord. This line does not pass through the center of the circle. It is drawn from here to there, or we can even put it from here to here, or there to there, or here to here, for as long as it does not pass through the center or the dot of the circle. And we have what we call a tangent. A tangent is a line that is touching the circumference. That is called a tangent. The line that is touching the circumference. And then we have the last one. We have what we call a secant. This one, it is a line that is passing through, meaning it is cutting the circle. It is cutting the circle. This line is called the secant. So now, these are the 5 lines that we have to take into consideration whenever we deal with circle geometry. Why am I saying this? Because in most of the questions, you will meet with this type of lines. So if you are not familiar with them, you will end up not answering or getting the answers correct. You will end up being lost in the middle of the way. So you need to be able to spot out these lines in each and every question that you come across. They are very important. So now, after this one, we are going to dwell into the first theorem, of circle geometry. Now, theorem 1. Theorem 1. This theorem states that the line drawn perpendicular from the center of a circle to a chord bisect the chord. Now, let me draw the circle. They say line drawn from the center of the circle to a chord bisect the chord. In other words, if we have a chord here like this, and then let's say here is our center, they say the line drawn from the center of the circle, drawn perpendicular to the center of the circle, the line drawn perpendicular from the center of the circle to a chord bisect the chord, meaning this line, let's call this O, and then let's call this M. Here, this point, let's call it M. So now, and then let's call this chord AB, meaning OM bisects chord AB. What does bisect mean? Bisect simply means AM is equals to MB in length. If this AM is 2, meaning even MB, it is going to be 2, meaning this line cuts AB into 2 equal parts. This is the first theorem of circle geometry. And there is a question to this type of theorem, to this theorem. The first one, they will say, prove, they will say, prove that AM is equals to MB. They will say you must prove this. And then they will give you that this side is equals to this side. Let's say they say M1 is equals to M2. This one is given. Now they say you must prove that AM is equals to MB. This is proof 1. Let's call it proof 1. How do you prove that AM is equals to MB? The first thing that you're going to do here, you are going to join. You're going to join OA just with dotted lines. You're going to join this OA and OB. And then from there, the second step, now we have how many triangles? We have 2 triangles, triangle AOM and triangle OMB. So now let us focus on those triangles and say in triangle AOM and triangle OMB. The first thing here, OM, the line OM is common. You will say OM is common in these 2 triangles. The second step, we're gonna say, okay, let's say let's label this. It's 1, it's 2. Angle M1 is equals to angle M2. The reason will be it is given. Remember that it was that prove that AM is equals to MB if M1 and M2 are equal. You were given that. Now the last step here, we'll say, okay, OA is equals to OB. Why? They are called the radii. They are called the radii. Line drawn from the center to the circumference. Line drawn from the center to circumference. They are equal. Therefore, this proves that triangle triangle AOM is congruent to triangle OMB, which simply tells us that if these triangles are congruent, now it shows that AM is equals to MB. This triangle, they are congruent, they are alike. So which means if they are alike, now AM and MB, they are equal. Why am I saying that? Because line OM bisect the chord. Bisect the chord. Now I have proven that AM is equals to MB.